Geometry class. This is Wednesday 4:15 and this is 12-2 solving right triangles, which is on page 582, and this one looks like it'll be a little shorter than the ones we've done, so that's nothing wrong with that. So before we start, I want to make sure that you get your calculator, have the setting of degrees by first tapping the mode button, which I think you've seen before several times, and then cursoring down to the third row. It says radians and degrees. Cursor in to degrees and enter it if it's not already selected. So on example 1, we have the right triangle with legs of square root of 3 and 1 and a hypotenuse of 2. And that's our 30, 60, 90 triangle. So for the first part, we look and see that cosine 30 is square root of 3 over 2, which we've done before. Now the reason you need the calculator set to degrees is now so we can type in tangent 72, and usually we keep these to 4 places, so that would be 3.0777. Make sure you can get the same. And then sine 26.2 is 0.4415 rounded to 4 places. Now in example 2, we have a base of 6, the other side of 8, and an angle of 72. So we know that since there's a right angle at angle C, that angle A, the one on left unspecified, must be 90 minus 72 or 18. Now to get B, the side B, we can say tangent of 72 is opposite over adjacent, or B over 8. And cross multiplying, we get B equals 8 tangent 72, 24.6. Now in a similar way, we can get side C by doing cosine of 72 is 8 adjacent over C hypotenuse. And then multiplying through again, C cosine 72 is 8, and dividing both sides by cosine 72, we get C is approximately 25.9, rounded to 1 decimal place. Now, in general, if sine A equals x, then taking sine inverse of both sides, we can say that sine inverse of sine A, now sine inverse and sine we've talked about cancel each other, leaving just the angle A, that's how we get angles, equals on the other side sine inverse of x. And in similar fashion, if cosine A equals x, then taking inverse cosine on both sides, cosine inverse cosine A leaves just A, because cosine inverse cosine cancel, A equals cosine inverse x. And similarly, if tangent A equals x, then tangent inverse tangent A equals tangent inverse x. And also, if sine 60 is square root of 3 over 2, then doing what we just did above, square root of 3 over 2, we can use as sine inverse square root of 3 over 2 is 60, having taken sine inverse of both sides and reversing left and right. Also, if cosine inverse is a half, now we say to get the angle, cosine inverse of 1/2 is 60. And if tangent of 60 is square root of 3, which it is, we can tangent inverse both sides and get tangent inverse of square root of 3 is 60. So that's how we get angles, using the inverse trig functions. So in example 3, we have triangle with side 3 and hypotenuse 5, allowing us to get sine A as 3 over 5, or using our inverse sine, A equals inverse sine of 3 over 5, giving us approximately 36.9. Now on example 4, the triangle with 11 and 17 for sides, we have again tangent A is 11, tangent B would be 11 over 17, there's a misprint there, sorry. And B is equal to tangent inverse 11 over 17. So angle B would be 57.1, and angle A would be 90 minus 50.1, 57.1, or 32.9. So here I have A and B mixed up, but I'm sorry for that mistake. But now C we would just use the hypotenuse for, C squared is equal to 11 squared plus 17 squared, which is 121, plus 289, which is 410. So C would be the square root of 410, or 20.2 approximately. Now in practical applications, when we look at the horizon as usually thought of as our x-axis, the angle above that is called the angle of elevation because it rises above the horizon, or the angle below the horizon is called the angle of depression. And when I used to work for the military for sonar, that's what boats use, is they have an angle of depression where they shoot the sonar beam below the surface of the water. So angle of elevation and angle of depression are used in many practical situations. For example 5, where we have a stretch of 2400 with an angle of depression of 7.5 and an X, which is part of a 7,000 foot high building or whatever it is, then we can now get our tangent of 7.5 would be opposite over adjacent, x over 2400. So cross multiplying, x is 2400 tangent 7.5, or 316. So the whole height, 7,000, take away 316, that x leaves 6,684 feet. Now on example 6, we have a base of 180 and an angle A of 43 degrees. So in order to get side C, the hypotenuse, we can say that cosine 43 is adjacent over hypotenuse, or 180 over C, and C times cosine 43 multiplying through is 180. Dividing both sides by cosine 43, we get approximately 246. Now the homework starts on page 585, and this is just, the first few are just pull-offs off the calculator, just have to type them in. So cosine 12 is 0.9781, real easy. Tangent A is 0.92151, requiring us to use inverse tangent to get the angle. So the angle A is tangent inverse 9.2151, or 83.8, rounded to the nearest tenth. And on problem 6, if sine C is 0.9915, then C, angle C, is the sine inverse of 0.9915, or approximately 82.5 degrees. Now on problem 8, we have a side or a height of y and a hypotenuse of 20 and an angle of 17 at the right base. So we can say that sine 17, which is opposite over hypotenuse, or y over 20, and then we can just cross multiply, y equals 20 sine 17, approximately 5.8. Now for 10, we have sides of 5 and 11, and we're going to try to find z, the hypotenuse. So z squared is equal to 11 squared plus 5 squared. It's equal to 121 plus 25, which is 146. So z is the square root of 146, which is approximately 12.1. Now on 12, if tangent h equals 5 over 11, then we know from what we saw in the notes that h equals tangent inverse of 5 over 11, which is 24.4 degrees approximately. And on problem 14, we have a base of x, a hypotenuse of 40, and an angle on top there of 21 degrees. So we can say that sine 21 is x over 40, and cross multiplying, x is 40 sine 21, or 14.3. On 16, we have a triangle with a base of 12 and a height of 15, and a hypotenuse of y. So first we go for the hypotenuse. Y squared is equal to 12 squared plus 15 squared, or 144 plus 225 equals 369. So then y, the hypotenuse, is the square root of 369, approximately 19.2 feet. Now to get angle x, we can go with the tangent of x. So tangent of x is opposite over adjacent, or 12 over 15, and we use the inverse tangent of 12 over 15 to get the angle x, coming out to be 38.7 degrees approximately. And we'll do, now for angle Z, we know that angle Y is right angle. So what's left, Z, is 90 minus the X angle, 38.7, or 51.3 degrees. Now on 18, we have a triangle with a base of 6, a height of 9, and an angle at A of 48 degrees. So we can then tell immediately that angle B is 90 minus 47, or 43, since we have a right angle for C. And tangent of 47 we can say is 9 over B. So when we cross multiply, B tangent 47 equals 9. Dividing by tangent 47 on both sides, we get 9 over tangent 47, which is approximately 8.4 centimeters. And sine 47 would be opposite over hypotenuse, or 9 over C. Cross multiplying again, C times sine 47 equals 9. So we divide both sides by sine 47, and we get 9 over sine 47 is 12.3. Now for problem 20, we have our right triangle with Q being the right angle and the sides being 26 and 42. So we go for the hypotenuse first. Q squared is equal to 26 squared plus 42 squared, and you sure need your calculators for this one. 676 plus 1746 is 2440. So Q, the hypotenuse, is the square root of 2440, or 49.4. Now the tangent of O is opposite over adjacent, so that would make that 42 over 26. And angle O is inverse tangent of 42 over 26, which is approximately 58.2. And as we've been doing all along, once we get one of the acute angles, we get the other one by 90 minus the first one. So 90 minus 58.2 is 31.8 for angle P. Now for 22, we have a base that's unknown. We're calling it side B, a height of 15, and a hypotenuse of 34. So in order to get the side, we use the right triangle theorem. 15 squared plus B squared equals 34 squared, or 225 plus B squared is 1156. Subtracting 225 from both sides, we get B squared equals 931, leaving us with B as the square root of 931, which is approximately 30.5. Now sine A is opposite over hypotenuse, or 15 over 34, so angle A is sine inverse of 15 over 34, or 26.2. And that would leave angle B to be 90 minus 26.2, or 63.8. For problem 24, we have a base of 18 and an angle of 47. So that immediately allows us to get angle B as 90 minus 47, or 43. And we can say tangent 47 is opposite over adjacent, or A over 18. And cross multiplying, A is equal to 18 tangent 47, or 19.3. And to get cosine of 47, we would have the adjacent over the hypotenuse, or 18 over C. And now cross multiplying, we get C cosine 47 equals 18. Divide both sides by cosine 47 leaves us with 26.4. And on the last problem, we have a base of 1006, an angle of 64 degrees, and a height. So tangent of 64 is opposite over adjacent. So h over 1006, cross multiplying, h equals 1006 tangent 64, or approximately 2062.6, and we're done. And I'm glad this is shorter for your benefit. God bless you, and I hope you're able to see a Facebook Live sermon tonight from your church. Keep in touch and just stay close to Christ. Keep Easter throughout the year. God bless you, and thank you for doing so well these first 2 weeks. I'm very grateful and I appreciate you, and I love you guys very much. God bless.